Hello, welcome to the tech shop at New Life Scientific. My name is Steve. Today I want to talk a little bit about the Cary line of spectrophotometers. We've done some videos on these. In preparation of one of the videos, the copywriter asked me why I seem to like the Cary line so well, and one reason is we've lost so few of them. What I mean by lost is they came in and there's nothing we can do with them and had to sell them for parts. Very robust, very rugged built units. They're very serviceable, and they give you some hands-on testing and tweaking of the tools with the software. So those are some of the reasons why. One of the tools is the align function that comes with the standard suite, the WinUV suite of software. There's a number of different packages. The align allows you to calibrate the unit, if you have a 6x6 Peltier transport unit, it allows you to calibrate the differences. It calibrates the lamp. You can use it to align your lamps in it when you change your lamps. So it's a lot easier to deal with on this unit than a lot of others. And it's this software right here that allows you to do it. We can select our test. Here we're going to run a wavelength accuracy with both deuterium and with the holmium oxide sample. When we run that test, when we selected that, we can run the test. It's going to run its series of tests. It tells you what's coming up and what you need to do, and it's going to run all its tests and deliver a report at the end of this. It takes a few minutes to run that, and we'll revisit in a minute. While it's going ahead and running those tests, we'll talk about how they're built and the robustness of the units. Very easy to open up. You've got some screws here on the side that you would take out. That allows you to remove the top. Here's where your lights would be. And normally that's got a cover onto it. You can remove the top. You've got your light tight boxes here where the light is going to go down through. Typically you don't need to go into that very often. There are typically two nuts right here that I've already taken off to speed this demonstration. Once those are removed, then you can get into the workings of this unit. This unit lifts up, gives you access to the internal. It has a kickstand. Sometimes there's different variations on this. There are different variations of the inside of it. This is a Cary 100. It's almost the identical layout of a Cary 300, but there are variations on the Cary 100. Some of the Cary 100s have a circuit board here that allows connectors come up through the bottom of the light panel. This one does not have it, so it cannot use a 6x6 transport unit, which is a very desirable unit. Anyway, the workings on these is it has one large robust motor that drives everything. The chopper, all that's driven on this one unit. These belts are very commonly broken when we get them. They're reasonably easy to change, although there's a trick to them. We're not going to go into depth on that at this point. One of the maintenance things that you might want to do on periodic time is there's an oiler pan right here that put a couple drops on that'll lubricate this actuation screw. This turns and it will drive your mirror adjustment. Put a couple drops on that periodically. Again, that's something that we do on a regular basis, as well as change those belts. Both of those are high failure points, but they're easily remedied onto it. So while we're here, as you can see, these are built like a tank. So they are made to last, and why so many of these units are still in the labs working. So there is typically a clip there to put on the stand. Here is where there would be connectors in the bottom for your accessory pack. There are sippers, there's all sorts of them, and then there would be your sample rack which bolts into those units. Put the cover back on, it's ready to rock. There's different type of nose pieces for the front here, depending on whether you have some type of Peltier controlled, temperature controlled unit installed. That's all done from a removable front. We'll show you that back in the front. So lamps are easy to get to, easy to adjust. The software, as we talked about, the Align software does allow you to do it. The UV lamp is there. This one we just pulled out of the tech shop. We're going to be replacing the white light lamp. It's fairly easy. It clips right in. It is typically aligned perfectly when you drop them in because of alignment pins that's on that bulb. But the software does allow you to tweak that just a little bit to get optimum performance out of your unit, and to make a judge on how well your lamps are. Lamps are a consumable item. They do go bad over time, and they get weaker on down the line. So they do need replaced periodically. So it's one of the things we test. Here's our certain. We're going to come back to our software. It's into the second phase, which is the holmium oxide test. Common test, what we've used for a long time. This test that we're running allows us to do a thing. We're going to put our sample into the unit. This is a 1x1 cuvee holder for the unit. Slides in. We're stuck to put that in. It's going to go ahead and perform that test. It's all going to be visible on the screen here as it runs to see its peaks, and then it's going to give you at the end here, and we're going to probably jump ahead in a few minutes, but it's going to deliver results that are verifiable. It knows what holmium oxide, of course, what the spectra should look at, where the peaks are, and it's going to test them. On the test, part of the test that it's done so far, it did a wavelength accuracy test. So it runs those tests, looks for where the scan range is, what the peaks should be, and where it found them, and then gives you a pass mile. Here's the explanation of what the test is, what the tolerances are. You can change those tolerances from the factory specs as well if you want a tighter or looser tolerance. And there's the first results. Since it's running, it's a little the screen's a little jittery because it's collecting this data in the background here. But it tells you what it does, what the status was that it passed, and what the tolerances was again. As I said, this becomes a printable, signable document at the end with date codes. So, okay, unit has finished running the wavelength accuracy test. Now it's delivered the graph here and a signable report, which we save onto the hard drive so that you can know that when you get it, that it's run. You're welcome to request this information on a unit. That's what the report will look like. It gives you exactly what is fine, again, what the tolerances are. And you can narrow those if you want, all in by customizing the report, the test run. As I said, there are other things that this Align software, which is the subset of it, there's a lot of other tests that it does run. Set control, the absorbance, there's all different tests it runs. Some of the tests, the other tests that we do use also is to align the Peltier units. Again, those are some of the tests to show you the test that it's capable of doing. So thank you. Look forward to having you take a look at our Cary line of spectrophotometers.